Today we're going to look at section 4.5, day 1. We're going to spend 2 days on this section, which are the graphs of sine and cosine function. So, where I want us to start is going back to our table. Even before that, let me go ahead and start off with this. That's your basic sine function. A is called amplitude. It's defined as how tall the graph gets. Okay, as far as tall goes, I mean vertically. It's going to be how vertical stretched is the graph. B will help you determine how slow or how fast the curve is. Okay, it's going to help you determine the period of the graph. Alright, I'll explain this in a minute. And what I want to start off by doing is talk about the basic if I want you just to graph the sine of theta. Now, if you think back to the table that we made, we have pi over 6, pi over 4, pi over 3, pi over 2. That takes care of quadrant 1. Now, using your table, pi over 6, the sine was 1/2. Pi over 4 was the square root of 2 over 2. If you type that into your calculator, let me just grab my chart for you. Okay, so where I'm getting these numbers from is this column right here. Okay, so square root of 2 over 2 is about here. Square root of 3 over 2, a little bit higher. And at pi over 2, we're at 1. Go back to 0. Do you agree that okay, so far I've got something that looks like this if I connect my dots. Now, in quadrant 2, sine still remains positive. Now, where I'm getting my numbers on my graph are coming from now this wagon wheel. I'm kind of morphing the two wagon wheels in one. So, from pi over 2, I'm going to go to 2 pi over 3. Then I'm going to go to 3 pi over 4. I'm going to go to 5 pi over 6. And finally to pi. Now, 2 pi over 3 has the same value as pi over 3 because we've established that sine is positive. 3 pi over 4, they would match. 5 pi over 6 would match the pi over 6. And at pi, I'm back to 0. So that's what the curve does in the second quadrant. Now I'm going to move on to quadrant 3. In quadrant 3, sine becomes negative. Alright, again, I'm morphing these two together. So I'm going to have 7 pi over 6, 5 pi over 4, 4 pi over 3, and 3 pi over 2. Okay? So they're going to take on the same values they have been taking on, but now I'm down in the negative realm. So pi over 6 is going to take me to negative 1/2, a little past, negative 1. So my curve continues downward. And if you haven't already guessed it, when we talk about the fourth quadrant, we're still going to be negative and we're just going to come up. So I have, what, 5 pi over 3, 7 pi over 4, ooh, running out of room, 11 pi over 6, and then 2 pi would sit out here. I've just run out of room. Okay, so here, 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 and back to the origin. Okay, so your basic sine curve. Oscillates between positive 1 and negative 1. And we're going to talk about just what it's doing at these points. So the sine curve will begin at 0. It will go up to positive 1, back to 0, down to negative 1, back to 0. So it takes 2 pi rotations to get me through. Okay? That's called the period. So the period of sine is 2 pi. So in other words, for sine to complete its oscillation, it has to go 2 pi. Alrighty? Now let's talk about how you're going to graph. It's going to be to graph y equals sine or y equals cosine x. So they're going to graph exactly the same. Step 1, identify the amplitude and period. Step 2, find the x values at the 5 key points. X sub 1 is where the cycle starts. X sub 2 is to take x sub 1 plus the period divided by 4. X sub 3 is x sub 2 plus the period divided by 4. And you keep going. X sub 4 is x sub 3 plus the period divided by 4. And x sub 5 is x sub 4 plus the period divided by 4. I understand right now that may not make a lick of sense to you, but it will as we graph one of these. Alright, so once you've determined where your key points are, then you find the y values at these points. Okay, number 4, connect the points. And step 5, extend if desired. That's going to really come into play with the cosine curve. Alright, so you ready? Let's try it. I think I'm going to get a fresh sheet of paper. You're going to need about a half a page. So example 1, graph. this is telling you to graph it over 1 period. Okay? Alright, so step 1 wanted you to identify the amplitude and period. So step 1. The amplitude is what's in the lead, so the amplitude is 3. The period is going to be hidden here. So it's going to be 2 pi divided by whatever your b is. Remember, b is what's behind the sign. So in this case, what's behind the sign is 1, so my period is just 2 pi. Right, so let's go over that one more time. Amplitude is super easy to find. He's in front. The period, you take 2 pi, the normal period, divided by whatever's behind sign. So 2 pi over 1 is 2 pi. Now, what I want to do is figure out the divisions. So I want to know where are my key points at. Alright, so step 2. You take the period divided by 4. So my period is 2 pi. 2 pi divided by 4 gives me pi over 2. So I'm going to come down here real quick and I'm going to start making a little bit of a chart. Because step 3, in my opinion, is going to be easier if you go ahead and put it in a chart. Okay, so your x values, we know we're starting at 0. And we're stepping pi over 2 to get our key points. So we're going to take 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is pi. 1/2 plus 1/2 is a whole. 1 plus a half is 3/2. 3/2 and 1 more half makes 2 wholes. Okay? Now, I'm going to leave a big space and then come over here and do the output. So here's where I'm going to put it into the function. Okay, keep your little chart handy. Alright, so here we go. So I know my function is y is equal to 3 sine of x. So I'm going to say 3 times the sine of 0. Well, grab your little sheet. The sine of 0 is 0. Now finish it up. 3 times 0 is 0. Alright, let's keep going. 3 times the sine of, this time my input is pi over 2. Okay, go back to your chart. The sine of pi over 2, remember this is pi over 6, pi over 4, pi over 3, pi over 2. So the sine of pi over 2 is 1. So 3 times 1 is 3. Now, to get these last guys, my chart's no longer going to be helpful. What's going to be helpful is my unit circle here. So when I'm at pi, remember this goes cosine and sine. So what am I at pi? My sine is 0. So I do 3 sine of pi, 0. So notice I did 0 to 3 to 0, and if you had to guess, you're going to guess this is going to be I hope you said -3. So let's try it. 3 times the sine of 3 pi over 2. Again, this isn't going to help me much. I need to look down over here. 3 pi over 2, I'm here. What is the sine's value? -1. And then finally, 3 times the sine of 2 pi. So go back to your unit circle again. Sine of 2 pi is here. Sine is 0. Okay, let's take our chart and put it on a graph. So I need to go up 3, down 3. I'm going to go ahead and do pi over 2, pi, 3 pi over 2, 2 pi. And now I'm ready to graph it. When x is 0, y is 0. So put a dot at 0, 0. When x is at pi over 2, y is at 3. Pi over 2, we're up at 3. When x is at pi, we're at 0. When x is at 3 pi over 2, we are at negative 3. And when x is at 2 pi, we are back to 0. Connect my points. And we're finished. This was step 4. Again, on the sine curve, most of you will be happy with the way it looks and you're not going to want to extend it. Okay? Alright, let's try another one. Let's say I want you to do y is equal to negative 1/2 sine x. Alright, step 1. Determine your amplitude and your period. So my amplitude this time is negative 1/2. That'll be interesting what that does. The period is always 2 pi divided by what's behind sine. In this case, it's 1. So my period again is 2 pi. I want to know the intervals that my key points happen at. So step 2, you take the period divided by 4. Okay, so these guys is always going to be the period divided by 4. So my period was 2 pi divided by 4, and we're back to the pi over 2 again, which is the normal key points that we would get with sine. Alright, now we're ready for step 3. Step 3, we're going to make our little chart. You're going to input an x, plug it into negative 1/2 sine of x, and you're going to output a y. Okay, so let's think. Our starting point is at 0. And we're going to step again by pi over 2. So 0 plus pi over 2 is pi over 2. Pi over 2 and pi over 2. 1/2 and 1/2 is a whole. 1 whole and a half is 3 halves. And 3 halves and a half is 2 whole pieces. Okay? Alright. So, I take negative 1/2 sine of 0. Go back to your handy dandy little table. The sine of 0 is 0. So, no shock there. What do you think your next value will be? It's a great question. Some of you, I bet, are thinking it's going to be negative 1/2. Some are thinking it's going to be positive 1/2. So let's see what it is. 1/2 the sine of pi over 2. Where do I get the sine of pi over 2? Go to your chart. Sine pi over 2 is 1. So it's negative 1/2 times 1, which is negative 1/2. Okay? Negative 1/2 times the sine of pi. If you had to guess, you have 0, negative 1/2. My bet is you're heading back to 0. Let's prove it. I'm at pi. Go down to your unit circle. At pi, sine is 0. So 1/2 of 0 is 0. Okay? Negative 1/2 sine of 3 pi over 2. Negative 1/2 sine of 2 pi. Alright, so let's find 3 pi over 2. Go down to your unit circle. 3 pi over 2, I'm down here. Sine is negative. So it's negative 1/2 times negative 1, which is 1/2. And then finally, I get negative 1/2 sine of 2 pi is 0, and I'm back to 0. Alright, let's do a quick sketch, and then we'll end the video. So my amplitude goes to 1/2 and to -1/2. I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so 0 is 0. This time I'm going to go down. Anybody want to guess why? Because your amplitude was negative, which causes your curve to flip over the x-axis. Alright, we'll pick up with this tomorrow when the period shifts. Alright, okay? So you guys have a great night.